Welcome to EPG Pathshala. In today's module, we are going to discuss about clouds, its introduction and classification. Water on this earth is always on the move through a chain of events or processes which is referred as hydrological cycle. It gets evaporated into the atmosphere. That is, it changes from liquid to vapor phase from the ocean and land surfaces like lakes, rivers, ponds and transpired from vegetation due to the heat received from solar radiation. The atmospheric water vapor eventually returns back to earth as liquid water in the low and middle latitudes and in solid form like snow or ice near the poles and mountains through the process of cloud formation and precipitation. In this module, we are going to discuss about cloud, its general importance, various mechanisms of cloud formation and different types of cloud and their heights. And also how to predict a rain bearing cloud, cloud cover with visual observation and acquaint with the cloud cover recorder. Let's start with what is a cloud. Cloud can be defined as a visible collection of very tiny droplets of water or ice crystals suspended in the air, usually at some height above the earth's surface. At any point of time, about 50% of the earth remains covered by various cloud types, about 1 to 2% of which could be rain bearing. The clouds can grow very tall or take a flat shape. The clouds are typically white but may also appear in different shades of grey to black. Apart from the hydrological cycle, clouds also play a major role in maintaining Earth's radiation and energy balance, which are important drivers for the weather system and for the sustenance of life on the Earth. The clouds are the main controller of the Earth's normal temperature. In general, the net effect of clouds depend on the amount of Earth's surface area covered by clouds, their thickness and altitude, condensed particle size and the portion of water and ice present in them. Now, we will see the occurrence of clouds and their classification. Clouds can occur at any level of the atmosphere wherever there are sufficient moisture and nuclei for condensation are available. In troposphere, almost all the clouds exist, although the tops of some severe thunderstorms occasionally pierce the tropopause. Because of the large range in temperatures and air movement in the troposphere, clouds vary in structure and composition. At least 4 different types of clouds can be visually distinguished by the simple eye observation and without the aid of any sophisticated instruments, like cirrus, which is hair-like, stratus, which is layered-like, cumulus, which is heap-like, and nimbus, which is water-bearing. Now, we will see the origin of cloud classification. The first attempt to classify cloud was made by Lamarck in the year 1802. In the next year 1803, Luke Howard of England published a classification scheme which formed the basis of the modern cloud classification. This was further improved upon by the people like Reno and Hildebrandt. Subsequently, the World Meteorological Organization, the WMO, has published detailed cloud atlas over the years. We will see the modern cloud classification. The present day international classification is based on the altitude of the cloud base and is being as the clouds are classified into 4 main groups: low, middle, high level and clouds with vertical movement. These classes are further subdivided either based on texture or other important characteristics to provide an easier way to identify the various cloud types. Thus, altogether there are 10 types of clouds in this world. Depending on the latitudinal belts, the height of occurrence from the earth's surface of the 3 levels of cloud varies slightly and it is shown in this table. You can see in this table the height limits of the cloud in different regions. The high level in the polar it is 3 to 8 km, at temperate it is 5 to 13 km and at tropical it is 6 to 18 km. Medium level clouds in polar it is 2 to 4 km height, in temperate it is 2 to 7 km limit and tropical it is 2 to 8 km limit. While the low level clouds are seen from the surface up to 2 km height. High level clouds. These clouds are in high altitudes and primarily composed of fine ice crystals as the temperature are so low. These clouds are typically thin and white in appearance. However, when the sun is at low angles on the horizon, these clouds at times may appear in a magnificent array of colors. Three types of clouds are included in this group: cirrus, denoted as CI, C capital and I small letter; cirrostratus, that is CS; cirrocumulus, that is CC. Cirrus clouds, fibrous thread-like or white feather-like clouds, and they resemble curly hair and appear in patches. The shape or pattern varies considerably depending on horizontal or vertical direction of wind flow at the cloud level. They form at temperatures below -40 degrees Celsius and consist entirely of ice particles. It has a brilliant white color because of the ice crystal. It is difficult to judge the contrast between the top and the base of this cloud. No precipitation occur at ground level, and only particle streaks, that is known as fall streaks, are often observed below. It produces a halo and other optical phenomena and thick enough to hide the sun. You can see the picture of the cirrus cloud in the slide. Now, cirrostratus. It is milky, translucent cloud wheel of ice crystal, sometimes causes halo appearance around the moon and sun. Depending on thickness, sunlight can transmit through thus cirrostratus and more widespread than cirrus. It resembles cirrus clouds as both are brilliant white and lack contrast between the top and the base. It is the first visible indication of an approaching weather front. They may progressively thicken to altostratus and then nimbostratus with lowering of cloud base as the front approaches. The third type is cirrocumulus. It is small, rounded, white puffs that appear in long rows. Small ripples in the cirrocumulus clouds resemble the fish scales and brilliant white with a spotty appearance. No precipitation occurs by this cloud. The many features resemble those of cirrostratus. It is found in a similar altitude range as cirrus but more broken in appearance, usually seen in the winter and indicate fair and cold weather, but in tropical regions they may indicate an approaching hurricane. Now, the middle level clouds. Because of their lower altitude, they are composed primarily of water droplets with varying thickness from relatively flat sheets of cloud to a more cumuliform appearance. At very low temperature or cold condition, these clouds consist of ice crystals. These clouds are brighter and less fragmented in appearance due to short distance from the ground and higher composition of ice crystals. These clouds move with slower speed than lower level clouds by the wind. However, the speed is apparent. There are three types of clouds in this group. They are altocumulus, AC, altostratus, AS, nimbostratus, that is NS. Altocumulus clouds. These are white or grey or both white and grey. Patch sheet or layers of cloud composed of rounded masses, rolls partly fibrous or diffuse and produce no halo phenomena. Altocumulus clouds differs from stratocumulus by element size and may occur at different level at the same time, but their movement depends on the wind direction at that level. Altocumulus clouds also develop within the structure of cumulonimbus. These are thunderstorm producing clouds. The precipitation within altocumulus can develop rapidly at the rear even though the cloud may be moving fairly rapidly. This will obviously influence the duration of rainfall as well as normally large cloud base. The second one is altostratus. It is flat, smooth, greyish or bluish cloud sheets or striated, fibrous layers with uniform appearance, totally or partially covering the sky. It develops at any time as a thick or thin layer through sun, can be seen and does not produce halo. Under an altostratus sheet, shadows of objects on the ground are never visible and it is an indicative of an approaching cloud mass associated with a cold front. It produces precipitation and when precipitation becomes persistent, it becomes nimbostratus and sometimes altostratus, develop during the afternoon and extend to cover most or all of the sky. Altostratus forms part of thunderstorms within or below the lower part of the anvil region. The third type is nimbostratus. This cloud, it's water-bearing cloud with light to heavy showers. It's widespread, light grey or white sheet of cloud that produces persistent rain or showers for considerable time. It lacks contrast due to light colors and very difficult to measure apparent speed and direction. The thickness may be more than 4 km and associated with warm fronts. The nimbostratus can develop or occur with most other types of clouds, and it can develop from altostratus if it becomes sufficiently thick to produce precipitation. Next is low level clouds. These are mostly composed of water droplets because of their low altitude, but at sufficient low temperature, these clouds may contain ice particles and snow. These clouds are not well defined, and because of clear turbulent motion, they have ever changing structures. They are faster than high or medium level cloud, and movement direction is same as wind direction at the ground level. Or the low level clouds are of two types, stratus ST or stratocumulus, which is represented as SC. Stratus clouds, its fragmented and thin layer or sheet is grey color with fairly uniform bases, which may give drizzle, ice prisms or snow grains. No halo formation except at very low temperature. It lacks contrast and vertical growth like cumulus and stratocumulus and move in the wind direction. It has same characteristics as fog but never appear on the ground. Depending on the wind turbulence, it causes different weather conditions including thunderstorms and thunderstorm development. Stratocumulus, as low as 450 meters to more than 1 kilometer or higher. It is puffy, grey and with more horizontal spread with darker base like cumulus and entirely of liquid drops enough thick to obscure the sun or moon. It has rare precipitation but in turn into nimbostratus and cumulus to produce drizzle, particularly in hilly or coastal areas. Sometimes stratocumulus appears in the form of rolling patches of cloud aligned parallel to each other. They can also appear in the form of broken clouds or globules. The sun, moon and generally the sky can be observed through the breaks of these clouds. The amount of stratocumulus covering the sky depends on the amount of moisture concentrated at that level. And the fourth type is clouds with vertical movement. The base of this type of cloud may be as low as 300 meters above the ground and composed of water droplets when the temperature is above freezing. But when the temperature is below freezing point, these clouds may consist of ice crystals and supercooled water droplets. These clouds can grow tall till the limits of troposphere or even exceed it at times. Huge amount of energy is released within the cloud itself through the condensation of water vapor. Cumulus and cumulonimbus clouds are the two main types of clouds under this category. Cumulus, its most familiar type of vertical cloud that appear white, puffy type like pieces of floating cotton and known as fair weather clouds. Cauliflower shaped, it is cauliflower shaped with dark and flat bases and bright has rounded tower tops. Cumulus humilis, it is one variant of cumulus clouds without towers and protuberance and indicative of fair weather. Cumulus congestus, the top of this type of cumulus cloud resembles the head of a cauliflower. These generally form by air rising as a result of surface heating. Most often, these clouds are found during daytime and dissipate at night. They generally produce only light precipitation. These clouds grow upward and can develop into giant cumulonimbus clouds that are associated with thunderstorms, usually form at altitude starting from about 300 meters above the ground to 1.5 kilometers. Cumulonimbus clouds. These are most massive and tallest heavy dense clouds with a considerable vertical extent, that is between 600 meters and 1.5 kilometers and even sometimes up to tropopause. It is in the form of a mountain or huge towers. It has a classic anvil appearance. It produces thunderstorms in summers associated with heavy rain, snow, hail, lightning and even tornadoes. It formed under conditions of deep convection and produce at least one pronounced shower. At lower levels, these cumulonimbus clouds consist of liquid drops, but as altitude increases, the cloud progresses through mixed phase and fully icy or glaciated condition. Under the base of this cloud, which is often very dark, there are frequently low rugged clouds either merged with it or not. And precipitation sometimes are in the form of virga, that is rain that evaporates before it reaches the ground. It appears in streak or shafts extending from the bottom of clouds. It can be often seen over a desert where low humidity and high temperature can cause rain to evaporate high in the sky. We have other cloud types like orographic clouds. This type of cloud is formed when air is forced to rise over elevated terrain. Cloud base is dependent on the prevailing condition, but is similar in range to that of other low level clouds. Orographic clouds are often in contact with the ground at the hilltop. These clouds often do not produce precipitation, but larger systems may produce drizzle. When heavier rain occurs, that could be due to thicker cloud above. These orographic clouds may contain liquid or ice depending on the prevailing condition and terrain altitude. Noctilucent clouds. These clouds are very thin and composed of ice crystal. These are the highest clouds in the atmosphere, located in the mesosphere at an altitude of approximately 85 km. They are only visible when illuminated by light from below, that is after the sun has gone below the horizon. They are most commonly observed in the summer months at latitudes between 50° and 70° north and south of the equator. So, to summarize, cloud is the visible collection of water droplets or ice crystals suspended in the air, usually at some heights above the earth's surface. These clouds play an important role in the global hydrological cycle, radiation and energy balance of the earth. A modest sized cloud 1 km in diameter and 100 meter thick has a mass equivalent to one B747 jumbo jet. But with all that mass being spread over such a large volume of space, the density or the weight for any chosen volume would be considerably small, and it does not fall on the earth because the rising air keeps the cloud floating in the air. The clouds can occur at any level of the atmosphere wherever there is sufficient moisture to allow condensation to take place. Almost all the clouds exist in the troposphere where most weather phenomena occur. We have seen there are 10 types of clouds recognized internationally based on the height of occurrence in the atmosphere and growth. They are cirrus, cirrostratus, cirrocumulus, altocumulus, altostratus, nimbostratus, stratus, stratocumulus, cumulus and cumulonimbus. So, depending on the distance from the equator, high, medium and low clouds occur. High clouds are cirrus, cirrostratus and cirrocumulus, which are primarily composed of fine ice crystals. These are typically thin fibrous thread or feather like and appear white, while middle clouds, which are primarily composed of water droplets, examples are altocumulus, altostratus and nimbostratus, and contain significant quantities of ice crystals, and these appear brighter and less fragmented in appearance due to their distance from the ground and high composition of ice crystal. Low clouds, including stratus and stratocumulus, are mostly composed of water droplets. The stratus clouds appear fragmented and thin and can also be in the form of a layer or a sheet. These clouds usually look grey with a fairly uniform base and may give drizzle, ice prisms or snow grains. Cumulonimbus clouds show great vertical growth with its base sometimes as low as about 500 meters from the ground, and thunderstorms in summertime are associated with such type of clouds. Thank you.